below average, and the other year you get above average. And therefore the average has a retro period of 2 years. This is also intuitive, but also if you make an experiment with the Gamble distribution, you will see that the averages, you can compute the river flow for a retro period of 2 years with the Gamble distribution, and you will see that you get the average more or less. I say more or less because I said under certain assumption the average has a retro period of 2 years. And the assumption is Gaussian distribution. If you use the Gamble distribution, you will get an average that is has a retro period of about 2 years. So, of course, if you start from the average, which has a retro period of 2 years, usually you want to estimate the peak flow for a retro period of 20, 50, 100 years. It means that you have to increase this average. It means that the frequency factor for increasing retro period gets higher and higher than 1. The frequency factor describes, I say again, how the average is increased for increasing retro period. It's indeed an interesting idea to split the dependence on location and retro period into factors. Why it's interesting? In order to understand why it's interesting, this splitting, let me describe how these two factors are computed, the index flood and the frequency curve. Of course, in order to apply the method, you need to know how these are computed. Let me start from the easiest one, the index flood. I said it's the average of the annual maxima. So if you have some data, if you have some annual maxima, you can simply compute their average. And you may say, but then what is the advantage? Because if I have annual maxima, you may say, I can use the Gamble distribution and the annual maxima method. I don't need to use a regional approach. Indeed, there is an advantage in doing that, in taking the regional approach. And what is the advantage? The advantage is that in estimating the average, you need less data than with respect to fitting a Gamble distribution. Why is that? Because I mentioned to you that when you estimate a peak flow, you shouldn't exceed with the retro period a number that is about twice the number of the observations. So I said if you have 10 annual maxima, don't go beyond 20 years of retro period. Why is that? Because for increasing retro period, you are increasing extrapolation. Extrapolation means that your estimate is not within the range of the data, and you get higher and higher uncertainty when you get outside with respect to the range covered by the data. So when you compute the average, you are always in between the range. So it has been proved that even if you have 2 observations, just 2 of them, computing the average is reliable. And if you have 10 observations, is plenty of information to compute the average. The uncertainty is very reduced. So indeed, when you have few data, it's reasonable to prefer the regional, the index flood method with respect to fitting the annual maxima. If you have 100 years of data, I have no doubt I would go with fitting a Gamble distribution and I would ignore the regional approach. Because, 100 years is a lot of information. If I have 5 years of data, I have no doubt I would go with the regional approach. So basically the average, the index flood can be computed in this way. If you have data, even a few data, then you compute the average. If you don't have any data, the literature proposed regression techniques to estimate the average. And the regression based on what? The explanatory variables are some key features of the catchment. And there are several regression approaches. I'm not going into the details because what you are required to do, given that the approach varies depending on the homogeneous region. So even in Italy, if you work in Emilia-Romagna, here, you have a regression expression for the index flood. which is proposed by the literature. If you move to Tuscany, the literature proposes a different expression, because these expressions are determined on an empirical basis by fitting observed data. So for Gold's location, they estimated the average and tried to relate the average to catchment features. So what you have to do as an engineer, you have just to look for the regional approaches that are proposed for your location, for your homogeneous region. And if you work in a European or United States environment, for any location you have a regional method available. And even if you work in many other countries of the world, of course we have not yet a complete coverage, but for many locations in the world it's possible to find a regression relationship for estimating the index flood. Okay. The frequency factor, how it's estimated. This frequency factor, you understand, it's a probability distribution because it's describing, it's a function of the return period. So basically, it's describing a random variable which depends on the return period. It's a probability distribution. And it may be a Gamma distribution. Or maybe a GEV distribution. More frequently, it's the GEV, because the GEV is more flexible than the Gamble. And how is this distribution estimated? Of course, we learned that distributions should be fitted by using data. So how is this frequency curve or growth factor, which is a probability distribution, estimated? We need a sample of data, of course. We need a sample of data to estimate it. And what is the sample then? The sample, first of all, is collected into the homogeneous region, of course, and it's made by annual maxima observed in the homogeneous region divided by the index flood. You see that you may write this expression in this way: Q x t divided by Ix is equal to the frequency curve. So basically, this is a probability. The frequency curve, it's a probability. And what is the random variable for which we compute the probability is given by the peak flow, and therefore the observed annual maxima divided by the index flood. So for any Gold's location, what you do is collect the annual maxima. For any location, compute the average. Divide the annual maxima by the average. You get for any location a sample. Put all the data together, all the adimensional data together, and estimate the distribution. With the advantage that the sample size is huge, because you are putting together, you are pooling data from several different locations. My suggestion now is to make a break, and I will start by asking you if you have any question, because I rushed a little bit. I think my feeling is that you fairly understood, but because I'm looking in your eyes. But if you have any question to ask, please, when I start, don't hesitate, okay? Because, you know, there is, everything is explained here, but of course when I'm speaking, I'm providing more details. Okay.